welcome back to CTLA4 Chronicles. I'm Jane.
Hi, and I'm Dan.
And this is going to be like our first intro podcast video. And we're going to kind of explain what our podcast is about and then what CTLA4 haploinsufficiency actually is. So I'm going to let Dan explain what our podcast is about because he's better at explaining than I am.
So the podcast is going to cover a lot about CTLA4 and what our family's going through, our point of view. But we also want to cover rare diseases and reach out to other people that are looking for either community help, information. So we're going to have a lot of medical on here. We're going to be talking from a very detailed view, trying to explain it. And then we're also going to go into like things that are just easier to digest. So if you have any questions or anything like that, please put it in the comments and let us know.
I love explaining like medical jargon and the stuff that we're going through, especially when, you know, other people are new to this or have been dealing with it but don't understand certain aspects, because I've dedicated the last 5 years to understanding what this disease is and like how it's impacted and kind of unraveled our lives a little bit.
And not just ours. Through all this, we were able to help so many family members. So we're going to cover that and their stories and everything that we're still doing today with our family and others trying to help. So we have stories from across the world, families that have come to the United States for help. We have families that we reach out to other countries to see what they're doing and what they're using and how they're thriving or surviving, what their symptoms are like. We're comparing medical systems and how, you know, effective it is to get help when you ask for help.
Yeah, because like this disease is so rare that it's like less than 600 people total diagnosed, and there's probably more, but currently that's who's been diagnosed. And because it's such a small group of people, you don't have the resources or the doctors or the medicine to treat it. Like we're on the, what was the way Dr. Glazer explained it, like the cutting edge of medical science right now. So we're going to see different treatments and stuff come out that are going to be helpful to those, especially our kids. It's very personal for us to see like advancements in that for their health. So maybe they don't have to go through such a grueling process like a bone marrow transplant, or if they do, hopefully not with as much toxicity with like the chemo and radiation and everything else.
Yeah, and then just talking about the numbers and how wild this is. Again, 600 people globally, and we have 8 in our family, while still testing other family members on Jane's side, because through genetic testing, we were able to find out that it came from her side of the family, which family members were affected.
Yep.
So.
Yep, all the way back to my grandmother, who is 98 and she's still alive, and her life story is like equally as crazy as ours, but that'll be another episode.
Yeah, she'll have different parts for her episode because it's quite long.
Yeah, well, just like Catalina's is going to be in separate parts too, because her origin story is wild. So what is CTLA4 haploinsufficiency? CTLA4 is a protein that's actually called cytotoxic lymphocyte antigen 4. And it is the throttle for the immune system. It tells your T cells when to turn off once they've been activated by a pathogen or whatever else is going to activate your immune system. In our case, that doesn't work. And so once the T cells are turned on and they're attacking the virus and whatever, once they've eradicated that, they don't stop, and they'll invade non-lymphoid organs, which is like your liver, your lungs, your brain, your muscles. That actually can impact any part of your body, as we've learned, unfortunately. It can be incredibly systemic.
And about this time, we'll insert some pictures of Catalina, because as we were learning what this disease was, and before we knew what it was and it was impacting her, she would be so swollen, she looked pregnant. And the reason she's not covered in scars is because she was so young when it started happening, and her body was able to adapt and her skin stretched out.
Yeah, it was very elastic, but her stomach would look like waxy. It was so swollen.
Yeah, you couldn't push your fingers on her, you couldn't hold her tight because she was in immense pain when it was happening.
Yep. And that was due to like just swelling inside her abdomen. Like she was in acute liver failure at one point. But she had a lot of intestinal swelling, and then I have some similar, or had similar issues where it was like the, I don't know, casings around your organs would swell. And that causes so much pain, and there's not much you can do for it because you can't reach that with creams or regular steroids. You have to take like corticosteroids, which are systemic, and they're great for putting out fires, but they are horrific for like long-term use. It causes immune dysregulation. We kind of talked about that and like what it looks like in Catalina, but it can also cause autoimmune diseases. And Catalina actually has Hashimoto's, which is funny because she's not on treatment for it. Her thyroid's still functioning, but her body's already attacking her thyroid, and her body is attacking her pancreas because she has antibodies to that, which will eventually lead to type 1 diabetes. And I think they said originally it was probably a 10% chance of her developing type 1 until I developed type 1 at 30 out of the blue. And they said that the odds of both the girls developing that, because they both have antibodies, is like much higher than expected.
But a transplant clears all the antibodies
Yeah.
and you'll be cured. So
Yeah, it's really quite wild to be like living in the middle of like the medical science, because all of the I had 7 autoimmune diseases before I went to transplant, and now they're all gone. I have some residual things that we're gonna have to tease out as I like get better and grow with this new immune system. My type 1 diabetes is completely gone. I don't even wear a Dexcom anymore.
Yeah.
So that's like pretty amazing. There's a lot of genetic information, and Dan and I were sitting here a few minutes ago trying to go over like how to explain the genetics of this. But CTLA4 is an autosomal dominant genetic mutation, which
don't worry, we're gonna break that down.
And it's on chromosome 2. Affected people have a 50% chance of passing this down to their children regardless of sex. In our case, it just happens to be that like all of the people we've tested that were positive in the family are women, which is kind of odd. But that's like just by chance. Honestly.
Yeah, and I mean, we're still testing family members to see what the results are, and if this net is larger, that we have to look out for and who needs this kind of help.
Yeah, because like the genetic testing is expensive, and it's hard to get genetic testing done on adults, which is kind of surprising. If you don't have like a kid to segue you into some of these things for like primary immune deficiencies, it is incredibly difficult to get doctors to listen to you, because they're like, oh, well, if you went through your whole life and now you're having problems, it's probably not genetic, it's probably environmental. And it's like, it muddles everything. So
yeah, the pediatric teams have always been like more receptive and open and wanting to do the extra testing and talk to us about what's going on and how it's affecting the family, and doing the pedigree to figure out everyone affected.
Yeah, and the pedigree is like your family tree. That's the term that geneticists use when they are literally breaking down like who's affected, who's not affected, who's been tested, who hasn't been tested,
what their symptoms are,
Yeah.
how have they presented their whole life.
Yeah, so I mean, Yale has a very extensive pedigree on our family. They're actually writing a research paper that we're hoping to maybe get copies of sometime soon. But it's like a whole breakdown of our family and what's happened, and how our specific mutation impacts the human body. Because there's like several different types of CTLA4 haploinsufficiency. And I'm sure there's doctors that are going to disagree with how I said that, but there's different mutations that happen within the gene, and that can depend on severity of your disease and like what that looks like within one family. So like our family has been diagnosed with a new or a novel genetic mutation that has not been seen in people before, which has been one of the struggles we had even getting help for this, because it was a variant of unknown significance. And a lot of times that just gets looked over in genetics because everybody has different mutations, and there's different variations all the time that don't cause disease.
Maybe right now would be a good idea to stitch in a pic, and we can show people kind of where our mutation is,
Okay.
and discuss where everyone thought this was an unknown significance because they assumed it was so minor, being so far down in the genetic line.
Yeah, because it's on the gene itself. It's at the tail end, or the plasmic tail, I believe. And originally they didn't think that a mutation there would disrupt the whole gene, and how it's
Yeah, 218 came in hard.
yeah. So there's supposed to be 223 amino acids that make up the CTLA4 gene, and ours has a stop codon at amino acid 218, which means those last amino acids are just gone. They don't exist.
Yeah.
Poof, fairy dust.
And so, with that being said, everyone has mutations. Nobody's DNA is perfect, and your deletes are at different points, all on every single chromosome. As soon as you get down to one specific function, has a delete when the programming stops. And on this CTLA4 that we have on our mutation in this family, everybody has the exact same delete, and was expected with normal deviation that this would be okay. And little did we know, it is not.
Yeah, not at all. It's been one heck of a ride. I think we covered how rare it is, right?
Yeah.
Not a lot of doctors, not a lot of medications. We've traveled the country. We've talked to people in Germany. We've sent blood to Germany. Didn't make it. Got stuck in customs, and all of our cells died. But
then we had another team come in the UK.
Yep.
They were able to pick up and contact that lab, get it together, and that's how we started getting into making this more clinical instead of research based. We've got support teams all over the world that we were talking to for doctors and other patients that are helping us out through this journey, so we can all grow together and get everybody healthier and find a cure.
Yeah, and right now, a bone marrow transplant is the only curative option for not just CTLA4 haploinsufficiency, but other primary immune deficiencies. When they're bad enough that like your options are you're either going to decline and probably die, or you're going to go through something that's going to change your life forever. And like in my case, I'm one of the only CTLA4 patients that's had a transplant that's like doing as well as I am right now. We haven't found many that we've talked to. I think there's only 50 total global that have ever had a transplant, and I think I'm probably highballing that number.
Yeah. That we can have fun time.
Okay.
Right.
Another aspect when you're navigating rare disease and genetics is when you're doing genetic testing, you're going to find other things. And we thought was an incidental finding of another autoinflammatory disorder is something called FMF, which is familial Mediterranean fever.
Which unfortunately came from my side.
We had a bet at one point, though, which is funny because the geneticist did not want to tell us who the FMF came from because they thought it was going to be some point of contention, but it was really, Dan and I, who was going to do the dishes that night.
Yeah, and we laughed because most of the things that have gone medically complicated and difficult have come from Jane's side of the family. This one was on me. So,
which was a surprise, actually, when they told me that. I was like shocked because I thought for sure it was me too. But FMF, Catalina has FMF as well as Dan, and their presentation is a little bit different, but it causes recurrent fevers, and then other like inflammation a lot of times in the joints and like GI tract.
Mm-hmm.
And it flares up. It's not something that's constant.
They have different triggers, so it could be either like a physical stressor that's been tolling on the body for too long. You could have an environmental. You could have ate something that set you off wrong. But generally it has to be something rather extreme that's happening or that you're going through, whether it's mentally or physically, that'll cause these reactions.
Yeah.
As well as puberty. So this is largely known to affect many individuals, male or female, during puberty. The funny thing about it is that you're supposed to have it on both sides of the family again to pass it on. Not the case here. Surprise, surprise. So we don't know which side of the family it came from. It was my mother or my father yet. But whatever parent has it had 2 mutations, and that's what caused it to activate. So instead of being a carrier myself, I'm affected. And I was able to pass that on to the children as well, and Catalina got it, which added so many complications to picking the donor. So donor choices, when we get into that for Catalina's full episode, we'll go down that rabbit hole into more details. But I was supposed to be the original donor, and then I couldn't be because of the FMF and how it presents. Doctors were worried that once I give it back to her through the bone marrow transplant, because there's no way she'd escape it if I'm going to be the donor, that we wouldn't be able to identify the difference between her body going through some form of rejection or other complication causing a fever, or if it was the FMF reacting to everything going on in her body causing a fever for that. So it would have made post-transplant treatment very difficult. It was kind of a tough call, a little upsetting for me that I couldn't be there for her to give her what she needed, because the match rate was so high.
Yeah, when they told us that he was a match, it was like, oh my gosh, we don't have to look in it. She didn't have a match. She does not have a match in the registry, which was just, it was like, oh my gosh, thank God that.
Yeah, somebody here at home can do it.
I remember I got the phone call at work from Dr. Prokop when she said, unfortunately we can't use Dan because he also has FMF, and it has to do with the monocytes, I guess. When you transplant those, you can't get rid of them the same way you can get rid of T cells.
Right.
And so like the reaction that could happen could kill her too, and that was the other thing. It was like it would cause a life-threatening reaction.
Right. And my other family members, my brother, my sister, I had cousins, their children. We tested everyone, and nobody was a match.
Nope. Unfortunately, Jack, however, is Catalina's match. He is a haplo match, which is a half match. I think he's actually a little bit better. He was a 6.
No, he's a half.
Was he half?
Yeah.
You were the 6 out of 10. Right, so it's still great. They'll take a half match donor, a sibling donor, over a fully matched unrelated donor, which is what I had for transplant, because I didn't have any family that could have donated, because my sister is also positive for CTLA4. But back to the FMF, one of the other driving forces behind both of these genetic mutations are cytokines. And cytokines are like huge. Some of you might know about them from COVID and COVID causing like cytokine storms. That is essentially what people with CTLA4 deal with when you have these flares or these activations of T cells and stuff that your body is, trying to fight off all at once. And for Catalina, it ended with her with like 105 fevers, completely unresponsive in the hospital, dying basically. Yeah. And it's crazy. And they're different pathways. So like for FMF, Catalina was on anakinra, which is an IL-1 blocker. It's an interleukin-1 blocker. And that stops the cascade process. So that stopped her fevers. And the medication worked okay, but we were only treating one problem. We didn't know about the CTLA4 yet. And then CTLA4 has several different cytokines, but the most important one that they look for is soluble interleukin 2. And that one feeds off of the identifiable, I guess, by T cells and stuff. So they measure that in the blood for people who are positive for this and then some other diseases and whatnot to see disease activity, because it does come down with Orencia and other, biologic medications that are used to block those things.
Yeah, and so through this process, we were able to distinguish the two problems. And once we got the CTLA4 under control, it helped because it put the FMF to sleep. So once the CTLA4 wasn't constantly being triggered and setting things off in her body, the FMF then stopped. And we saw the swelling come down, and she would go from looking like she was holding a bowling ball for a stomach to looking like a normal child.
Yep. Being able to wear like normal clothes and stuff. Her diapers and stuff, we used to have to put them on her like weird because her stomach was so big we could not it just wouldn't fit. It was crazy. But that is why we are starting this podcast and want to help spread the word on rare diseases and specifically about like CTLA4 and how the heck you navigate a life like this.
Yeah.
Thanks for joining us on CTLA4 Chronicles. Hopefully next time we are a little bit better put together. This is all new to us, but
we're going to do this adventure together.
Yep. See you next time. I wanted to do finger guns.
I felt it. Because I did it.
I did it in my interview.
I did it, and then you ended with one gun. You're like,